Right now, your smartphone microphone is actually physically capable of hearing sounds that are completely invisible to the human ear. And what's kind of concerning is that hackers know exactly how to use those silent frequencies to, force your phone to take actions while it's just sitting right in your pocket.
It really sounds like a paranoid science fiction plot, right?
Yeah, completely.
But it's actually a fundamental reality of the hardware we carry around with us every single day. I mean, we expect major technological shifts to be obvious. We expect them to announce themselves with neon signs or, flying cars.
Right, like some big futuristic reveal.
Exactly. But the truth is, the most powerful technology in human history didn't arrive in a spaceship. It really just quietly slipped into your pocket.
Well, welcome to our deep dive. Today we are talking directly to you, the learner, the person who wants to understand how the world actually works without needing to, enroll in a full computer science program.
Yeah, we're going to unpack the invisible artificial intelligence that is already deeply embedded in the tools you use every single day.
And we're looking at a pretty massive stack of research today, covering the underlying mechanics of your smartphone, your navigation apps, voice assistants, and your social media feeds.
Right. The goal is really to trace a typical day in your life and reveal this massive silent infrastructure of AI that makes it all function.
And we are not just going to list off a bunch of tech buzzwords either. We want to really get into the mechanisms, like how do these things actually work?
Because once you understand the logic driving the software in your car or the thermostat in your hallway, your relationship with those devices completely changes.
Exactly. So let's start right at the beginning of a typical day, the morning commute. You get in your car, you open Google Maps, and I mean, for years, I just thought of it as a digital atlas. It's just a map that uses GPS to know where my car is.
That's how most people think of it, yeah.
But looking through the sources, calling it a map is a massive understatement.
Oh, it really is. It's much better to think of it as this massive, constantly evolving probability engine.
A probability engine.
Yeah. When it calculates your ETA, your estimated time of arrival, it isn't just looking at the distance and the speed limit, it is processing this enormous database of historical traffic patterns.
Okay.
Like, it knows, for instance, that the 280 freeway in Northern California routinely moves at a brisk 65 miles per hour at 6:00 a.m., but then it slows to a frustrating 15 miles per hour by 4:00 p.m.
Sure, so it remembers how traffic usually behaves.
Yeah.
But I mean, traffic is chaos, right? One fender bender completely ruins that historical average.
Which is exactly why the memory is just the baseline. It layers real-time, live traffic data over that history. And to make sense of all this, Google actually recently partnered with DeepMind to implement something called graph neural networks.
Okay, now graph neural network sounds like something straight out of a cyberpunk novel.
Mhm.
Are we talking about mapping the physical roads like a digital brain? Like, how does that actually change my drive to work?
It changes how the system understands cause and effect. So think of a city's road network not as isolated streets, but as a complex web. Graph neural networks are specifically designed to analyze these interconnected webs by looking at spatiotemporal interactions.
Meaning how space and time relate across the grid.
Exactly. So if there is a sudden traffic jam on a major bridge, a traditional system might just mark the bridge red.
Right, and tell you to avoid it.
Yeah, but a graph neural network understands the temporal cascade. It knows that a jam on the bridge at 8:00 a.m. will inevitably cause congestion on, say, three specific surface streets by 8:15 a.m.,
Oh, wow.
and then a backup at a highway on-ramp 3 miles away by 8:30 a.m. By predicting that ripple effect, they actually reduced inaccurate ETA predictions by over 40% in cities like Sydney.
Wait, really? It predicts the ripple effect before the cars even get there. That makes a lot of sense. But what happens when the baseline history becomes entirely useless?
Oh, yeah.
Like the research highlighted the beginning of the COVID-19 pandemic as a massive stress test for this. Global traffic dropped by up to 50% almost overnight.
It was wild.
Yeah, so the historical data from 2019 would have been actively giving the AI the wrong answers for 2020.
It was a fascinating crisis for predictive models, honestly. The AI was looking at an empty highway on a Tuesday morning and practically short-circuiting because its historical data insisted there should be thousands of cars there.
Right, the math didn't add up anymore.
Exactly. The engineers had to intervene and make the AI models agile. They reprogrammed the system to automatically prioritize traffic patterns from just the last 2 to 4 weeks.
Oh, interesting.
Yeah, while actively decaying the weight of any data older than that.
So it essentially had to be forced to forget the old normal so it could even comprehend the new normal.
Precisely. And, while mapping traffic flow is impressive, how the AI physically visualizes the world is even more complex. Let's look at the immersive view feature.
Oh, this is where the AI takes flat pictures and builds a 3D world.
Yeah.
I was trying to visualize how it does this without just guessing. Instead of a jigsaw puzzle where pieces just snap together, it seems more like it's using stereoscopic vision, like how having two eyes gives a human depth perception.
That is actually a much more accurate way to look at it. The technology is called advanced photogrammetry.
Okay.
Google takes billions of flat 2D images. Some are captured from street view cars driving by, others from people walking with those backpacks called trekkers.
Yeah, I've seen those guys walking around.
Right. And others from airplanes flying overhead. The AI looks at the tiny differences in angles between a shot from the street and a shot from the air.
Oh, I see.
By calculating the difference in perspective, it can mathematically deduce exactly how far a door is from the curb, essentially sculpting a 3D building out of flat photos.
And it isn't just mindlessly building geometry either, because the computer vision algorithms actually recognize what they are sculpting.
Exactly.
Like, the AI knows that a slow sign in the United States is a yellow diamond. But if it is rendering a street in Japan, it recognizes that the same warning is a white and red triangle.
Yeah, it categorizes the world. It labels building entrances, crosswalks, bike lanes. And because moving a digital camera through this synthesized 3D world can look jittery or robotic, the engineers use a mathematical construct called a B-spline curve.
Right, I saw that term in the research, B-spline curve. What is that actually doing for the user on their phone?
So it's a formula used in computer graphics to create a perfectly smooth path between multiple disconnected data points.
Okay.
Instead of the camera snapping rigidly from one street corner to the next and giving you motion sickness, the B-spline curve calculates this flowing, aerodynamic flight path.
Oh, so that's why it looks so cinematic.
Yeah. They also use a rendering trick called occlusion. This hides the blue navigation line when it passes behind a 3D building or a tree, which makes it feel like a physical ribbon laying on the actual city.
So when I ask for directions, the AI is weighing road quality, like whether a street is paved or dirt.
Yep.
It's pulling authoritative government data on toll roads, checking crowdsourced incident reports, applying a graph neural network to predict traffic ripples, and rendering a 3D flight path using photogrammetry and B-spline curves, all in the millisecond before my screen even loads.
That is the invisible infrastructure at work.
That's incredible. So maps predict where we are going physically. But as we move through our day, we interact with systems that try to predict what we mean linguistically. Which brings us to the voice in your pocket. Siri, Google Assistant, Alexa.
Right, and our mental model of how a voice assistant works is largely stuck in the past. When they first debuted, it was a linear pipeline.
Audio goes in, text comes out.
Exactly. Audio goes in, it gets translated to text, a basic search is run, and the answer is read aloud. It was very binary and straightforward.
But the sources describe modern assistants not as pipelines, but as a living loop. And this loop has very distinct anatomical parts.
It does. So first, the microphone captures the raw audio, then automatic speech recognition, or ASR, transcribes it. But instead of just searching that text, it feeds it into the assistant core. This is where a large language model is sitting. And it doesn't just read the text, it accesses a context store.
The context store?
Yeah.
That sounds like a short-term memory bank?
That is exactly what it is. It remembers that 2 minutes ago you asked about the weather in Chicago, so if you suddenly say, "Remind me to pack an umbrella," it links the two concepts.
Right, because otherwise, why would you bring up an umbrella out of nowhere?
Exactly. Once the core figures out what you want, it hands the instruction to a tool layer.
The hands that actually do the work.
Yeah. The tool layer reaches out to your calendar app or your smart lights, executes the command, and passes the result to the text-to-speech engine so the assistant can talk back to you.
So it's a constant looping ecosystem. But what I find really fascinating is the natural language processing, the NLP. Because human language is incredibly messy.
Oh, it is entirely contextual. The sources use a great example of this. Think about the difference between telling an assistant, "Remind me about the meeting," versus "Give me a heads up about the meeting."
To you and me, those mean the exact same thing. But to a computer, "Give me a heads up" is a bizarre string of unrelated words. Like, does the user want a physical head moving upwards?
Exactly. The NLP algorithms have to peel back our casual phrasing to find the underlying intent.
And because that intent processing requires massive computing power, your phone often isn't doing the thinking itself. It is silently streaming your recorded audio to cloud servers where the heavy lifting happens. Which brings us to the vulnerabilities of relying on always listening devices.
Right.
This is where we get back to that silent frequency hack I mentioned at the start of the deep dive, the dolphin attack. I really need to understand how my phone can take orders from a sound I cannot even hear.
It comes down to the physical constraints of the microphones inside modern electronics. They use something called MEMS microphones, micro-electromechanical systems.
Okay.
They are microscopic, cheap to manufacture, and highly sensitive. To ensure your voice sounds crisp and clear on a phone call, these microphones are designed to capture a very broad spectrum of sound.
But by making the net so wide, they accidentally catch things completely outside of human perception.
Yes. Humans generally can't hear frequencies above 20 kilohertz. But a MEMS microphone picks up those ultrasonic frequencies perfectly.
Wow.
So in a dolphin attack, a researcher or a hacker takes a normal voice command like, open the smart lock on the front door, and modulates it onto an ultrasonic carrier wave.
And then just broadcast it.
It broadcasts silently. You hear absolutely nothing, but your phone's microphone vibrates, processes the wave, translates it back into audio, and executes the command as if you had spoken it out loud.
So we engineered our devices to be vulnerable just so our voices would sound a little crisper on a Zoom call. That is wild.
It's a trade-off, yeah.
And it's not just targeted attacks that are the problem. There's the issue of accidental activations.
Yeah.
The microphone mishears something, wakes up, and just starts recording a private conversation to send to the cloud.
We've all experienced our phones lighting up when we didn't address them. Like if you say a phrase like, "Are you serious?" The acoustic pattern is surprisingly close to Siri.
Right.
The device wakes up and can capture minute-long audio snippets of whatever is happening in the room.
So how is the industry defending against this? Is it just a software patch, or is there an actual physical fix?
There's a brilliant defense system mentioned in the research called ECOS, Ensemble for Keyword Spotting.
ECOS.
Instead of just analyzing the digital audio file, ECOS analyzes the physics of the sound wave itself. When a biological human speaks, our vocal cords, our throat, and our chest cavity create these tiny secondary vibrations called harmonics.
It creates a physical resonance.
Right. A flat speaker cone emitting a spoofed audio file or an ultrasonic wave cannot replicate the complex physical resonance of human body.
Oh, that makes so much sense.
ECOS listens for those specific biological harmonics. It uses physics to verify biology before it allows the assistant to even wake up.
So it listens for the throat, not just the word. That is an incredibly elegant solution to a pretty terrifying problem.
It really is.
So we've looked at how AI predicts our physical movement through the world and how it predicts our linguistic intent when we speak. Let's transition to the spaces where we aren't actively commanding the AI at all. The spaces where the AI is, passively managing us. I'm talking about our social media diets in our smart homes.
This is a profound shift in the relationship. When you are scrolling through a social media feed, you are interacting with algorithms designed to completely predict your attention.
Right.
Meta's AI, for example, isn't just looking at what you like or comment on, it is measuring dwell time.
Dwell time, like how long I just pause on something.
Exactly. It tracks how many milliseconds you hover over a specific image before scrolling past. It pulls contextual behavior across Facebook, Instagram, and WhatsApp to build a highly accurate psychological profile of what keeps your eyes on the screen.
And what really caught my eye in the research is that the AI isn't just curating the feed anymore, it is actually creating it. Like, there are tools like FeedHive or Flix Iris Assistant that are being used by creators to brainstorm, draft, and automatically publish posts. They analyze what time of day your audience is most vulnerable to engagement, and the AI just writes the copy to target them.
It's entirely automated.
The line between a human sharing a thought and an AI generating an engagement trap is completely gone.
The environment is largely automated now, and we are inviting that exact same predictive automation into our physical environments through smart homes. The industry actually calls it judgment support.
Judgment support, basically the house making decisions for you.
Yes. A smart thermostat isn't just a timer anymore. It correlates data points. It might use motion sensors in your hallway to learn exactly what time you walk toward the kitchen every morning.
Oh, wow.
It checks the weather forecast. And over a few weeks, it learns your routine so well that it begins adjusting the climate control 20 minutes before you even open your eyes, ensuring the house is exactly 70 degrees when your feet hit the floor.
And smart kitchens are doing the exact same thing. The sources point out that modern ovens are tracking historical usage logs. Like if you always bake something at 400 degrees at 6 p.m. on a Tuesday, the oven will eventually just offer to preheat itself before you even walk in the door.
Yeah.
The refrigerator is monitoring inventory and power draw to suggest recipes based on what's expiring on the middle shelf.
It feels like the house understands you. It really feels like these systems possess genuine intelligence. But this is where we have to confront the most crucial limitation of the AI powering all of this. We really need to talk about the concept of the stochastic parrot.
The stochastic parrot. This is arguably the most important concept in the entire deep dive. Let's really break that down because it completely shatters the illusion of the smart home and the smart feed. What does stochastic actually mean in this context?
So stochastic refers to systems that are determined by random probability distributions. They can be analyzed statistically, but they aren't driven by logical reasoning. When researchers call large language models stochastic parrots, they are pointing out that these incredibly impressive systems do not comprehend meaning.
They mimic understanding without actually possessing it.
Yeah,
They're basically just probabilistic text generators.
exactly. An LLM knows which words statistically appear next to other words based on billions of examples in its training data. Let's use a geographical example.
Okay.
A stochastic parrot can easily output the sentence, Paris is the capital of France, because those words are clustered together constantly on the internet. But without enough diverse contextual training, that same AI might completely fail to logically deduce the inverse.
Which is that France is the country where Paris is the capital.
Right.
Wait,
Yeah.
really? Because it hasn't mapped the concept of what a country actually is. It just knows the mathematical probability of the letters Paris appearing near France.
Precisely. It has no internal model of the world. It doesn't know what a capital is. It's a parrot that has basically memorized the dictionary. It sounds incredibly smart. It perfectly mimics the cadence of human intellect. But if you push it slightly outside its statistical training, it hallucinates. It confidently generates nonsensical or entirely false information simply because the mathematical probability of that specific word combination was high.
So the AI drafting the social media post about mental health has no concept of human emotion.
Yeah.
The algorithm predicting my commute doesn't know what a car is. The system preheating my oven has zero concept of hunger. It is just math executing probability.
Yes. And understanding that distinction is absolutely vital. If we trust a stochastic parrot to handle complex, nuanced human interactions like customer service or curating our news or managing our daily schedules without recognizing its fundamental lack of comprehension, we expose ourselves to massive blind spots.
It is the ultimate illusion.
Yeah.
And that really brings us to the big picture. Let's sort of synthesize what we've unpacked today.
The overarching reality is that AI is not a futuristic event on the horizon. It is the invisible structural reality of today. It is the graph neural networks measuring the spatiotemporal ripples of traffic to guide your car. It is the complex living loop of natural language processing trying to deduce your intent, while engineers design physics-based defenses to protect your microphone from silent ultrasonic hacks.
Yeah.
And it is the stochastic parrots driving engagement on your social media feeds and acting as judgment support in your living room.
It is quite literally everywhere, just calculating probabilities in the background of our lives. And that leaves me with one final thought I want to explore with you.
Okay.
We started this by talking about how AI slipped quietly into our pockets. Our environments are mastering predictive automation. The algorithms are learning our routines so thoroughly that they pick our routes, draft our messages, and preheat our ovens before we even realize we need them to. They're building a world perfectly tailored to our statistical habits.
They are.
But if our daily reality becomes entirely managed by a stochastic parrot, a machine that fundamentally doesn't understand meaning, but only knows how to predict what we usually do, what happens to human serendipity,
Oh, that's a great question.
do we risk trapping ourselves in a perfectly optimized bubble where we only ever experience things that align with our past data? If the invisible infrastructure constantly feeds us exactly what it calculates we want, how do we ever stumble upon something delightfully unexpected?
Right.
How do we discover a new interest, a strange new route, or a challenging new idea if the algorithm has already decided it doesn't fit our mathematical profile? It's just something to mull over the next time your phone predicts exactly where you are driving before you even turn the key.
It really is the tension between total convenience and genuine discovery. A perfectly optimized life leaves very little room for surprise.
It really does. Thank you for joining us on this deep dive. Take a look around today and see if you can spot the invisible AI working in the background of your own routine. Until next time.